In this video, I'm going to work through a volume trade-off decision, assuming constraint as part of differential analysis. We're presented with a company that has three different products, A, B, and C, and they present both the selling price, variable expenses, contribution margin, and contribution margin ratio. If we didn't have a constraint, what we'd focus on is that product that earns us the highest contribution margin. And in that scenario, it's B at $100 per unit. Next would be C at $60 per unit. And last but not least is A at $54 per unit. But, however, like in the real world, typically there's something that limits us from selling as much as we'd like to sell, and that is raw materials. We only have 6,000 pounds due to a strike to one of our suppliers. Because of that, our decision shifts from just contribution margin to contribution margin per unit of the constrained resource. And in this example, because raw material is the constrained resource, it'd be contribution margin per pound of the constrained raw material. So let's work through this together with A. Again, the contribution margin per unit for A is $54. We need to divide that by the number of pounds it takes to make in unit A. Unfortunately, they don't give us the number of pounds. They do give us a piece of information that's going to be helpful. They give us that the direct material cost in A is $24. Why is that helpful? Because they also gave us that the material cost per pound is $8. Well, if there's a total of $24 in material cost and it costs $8 per pound, 24 divided by 8, it must have taken 3 pounds to make a unit of A. Now that I know it's 3 pounds, divide the 3 pounds into the contribution margin per unit, $54, and we get the fact that our contribution margin per pound of raw material is $18. Again, what does that mean? For every pound of raw material we use to make an A, we earn $18. Again, every pound gets us $18 for a unit I make for A. I'm going to let you, in the interest of keeping this video, I know it's already going to be long because it has multiple parts, but keeping it as short as possible, make sure you work through the calculations for B and C. I want to at least present the solutions because we're going to need that as we work through other parts. B earns us $10 per pound, and C, $15 per pound towards C. So now, given this constraint, remember before it was B was the first one we were going to produce. Now B is last. A used to be last. Now we've shifted to A at $18 per pound first, C at $15 per pound next, and B is the last one at $10 per pound. Assuming unlimited demand, which isn't realistic in this scenario, on only 6,000 pounds, meaning, we can sell as much of any as the product. There's just completely unlimited demand. What's maximum contribution margin? I'm simply listing here the already calculated contribution margin per pound for A of 18, B $10 per pound, and C $15. Individually multiply each of these times 6,000. Why 6,000? Well, this was the amount per pound, and there's 6,000 pounds. What am I going to focus on if I have unlimited demand? I'm going to focus on that one that earns me the most money. I would only make A. If I have unlimited demand, I just keep making A. If I'm not forced to make any of the others. And so the maximum contribution margin you can calculate on your own would be 18 times 6,000. Now I'm going to shift gears. What if it's a little bit more realistic of what we would face in the real world, and there is a limit to demand, still 6,000 pounds, but the limit to demand is 500 units per product line. So now that's going to make it a little bit more challenging. Again, what would be our starting point? Our starting point would be the unit that earns us the most per pound, and we've already said that's $18 per pound. So let's think about that and the amount of poundage that we'd need. Well, if we make 500 units of A, because that's the max, how many, and I'm going back to a previous part of the problem, how many pounds did it take to make per unit? We already worked out $24 in total divided by $8 per pound means it would take 3 pounds. So 3 pounds per unit times 500 units, we would need 1,500 pounds of material to make those 500 units of A. So if we're taking 1,500 pounds of material to make 500 units of A, and they earn $18 per unit. The maximum we can earn from A is $27,000. Now, I will note you could have figured this out another way. You could have said 500 units of A times $54 per unit also is $27,000. Just make sure whatever you're doing for contribution margin, you're also doing for units. Well, how much material do I have left? I had 6,000 pounds. We used 1,500 to make 500 units of A, so I have 4,500 left. Where am I going to go to next? I'm going to go to C, which earns me $15 per pound. Now, I have 500 units of C times $4 per pound. I realized that I didn't fully, I was hoping you'd calculate this on your own through the first video. I'll go through this quickly. $32 of material cost for C divided by $8 per pound is 4 pounds. That's how I backed into that. So 4 pounds to make all 500 units of C means I need 2,000 pounds. I have 4,500, so I can make all 500 units of C. Again, I need 2,000 pounds times $15 per pound. The amount that I can earn from C is 30,000. Also, another way, 500 units of C times $60 per unit would also be the 30,000. So you can approach it from either direction. Now, I still have some material left, correct? 4,500 minus 2,000, 4,500 left after I made 500 units of A. Take 2,000 additional pounds to make 500 units of C, and I have 2,500 pounds left. I feel like I'm going to get to a point where I probably can't fully make all the Bs that I want to make, so let's test this out. How many pounds does it take to make a B? So I'll work through here. We have direct material costs of $80 for B up here. Divided by $8 per pound means it takes 10 pounds to make of raw material to make B. 10 pounds divided by 2,500 pounds remaining means I can't make all 500 units of B. I can only make 250 units, which, you know, cut both ways. At least I can make some, but I can't make everything that I want, but I can get into some of it. So I'm going to use the remaining 2,500 pounds at $10 per pound and earn $25,000 from B. Again, another way I can look at it is 250 units times $100 in contribution margin per unit also is $25,000. Now, the question asks, what's the maximum contribution margin? I'm going to have you work this out on your own. Simply add up the 27,000 plus the 25,000 of B plus the 30,000 of C. So if demand is limited to $500 per unit and you still have the constraint of 6,000 pounds of raw material, the maximum that you can earn is the three of those added together. One last part of the problem says, what if you can buy some raw material from someone else than your normal supplier, and you know that there's going to be a premium? Now, I want to stipulate, don't forget, assume all the requirements from 3. 6,000 pounds of material, and the demand is only 500 units. So what is the only thing that still we haven't fulfilled all the demand? That is B. Remember, we've already filled all the demand for A, and we've already filled all the demand for C. We only filled 250 of the 500 units wanted for B, so that's a fact to remember. So why am I stressing that? Again, they're saying, what is the maximum amount that you'd be willing to pay for that raw material? Well, I'm not going to work through everything, but I'm giving you a hint. Again, B is the only one. B earns me $10 per pound. To find the maximum amount you'd be willing to pay as a premium, take the $8 you already pay for material, and to that, add the contribution margin that you're earning per pound for B, and that would be the absolute maximum price. Again, $8 regular price plus the $10 in contribution margin that you're earning for B, that would give you the maximum absolute price that you're willing to pay. Now, if you pay that maximum price, you're not going to earn any profitability for B. Maybe at least, though, you know you're making customers happy by complementing the other product lines, but it's a negotiating factor. You're like, hey, somewhere in between that $8 and the maximum I'm willing to pay, at least I know that's a negotiating range.